Okay. Now, okay, all right. Real quick. Okay, we graphed -7, -1, and 5, correct? Okay. Now, what this should look like. Now, I don't mind which direction you start with, up or down, it really doesn't matter. So -7, -1, 5, it should maybe look something like this. Maybe some of you had a drawing like that. Did anyone want to have it going the opposite direction where you started up and went down? Anyone go there? Okay, that's fine. Because I didn't really tell you how to do it. I mean, it was just kind of a free-for-all, -7, -1, -5. Some people like to do this. That's fine, as long as it's flowing and continuous from one side to the other. I don't know where your peaks and valleys are. That's something that we do in Calc that we'll eventually can figure out. Okay, the goal today is to again discuss how transformations work, how to manipulate this graph, drag it right and left. We'll talk about that today. Yesterday we did up and down, so we'll kind of review that. We talked yesterday, I think one of the problems we did, we stretched it vertically. Now what we're going to talk about today is compress it vertically. And then we're going to look at, other than rotational stuff, how do you rotate? We're going to look at, we're going to start today with how to compress it, like horizontally. And that's something we've never done yet. Now the reason I bring this problem up, this is one that we did yesterday. This is something we're going into in this chapter, is being able to graph polynomial functions. Something that has more than just a linear function to it. There's actually like curves, hills and valleys. But we're looking for continuous functions. We're not looking for piecewise stuff. So something that's flowing, okay? This is one type of drawing. Now, what we talked about yesterday was how to come up with a function, a formula that would represent some form of this on a calculator, right? So what we talked about yesterday was taking each of these x values, -7, -1, and -5, and making each of these their own binomial. Okay, so what I mean by a binomial is that you make these into parentheses like x plus 7, x plus 1, and x minus 5. And how we did that, like how I set that up yesterday, is I talked about you had to make a polynomial equation that when you solved it, like when you set this thing equal to 0, it would give you this answer out. Make a polynomial equation that when you solve this out, it would equal -1. Solve this out, it would make +5. Does that make sense? And what we did yesterday was one of the problems you had to take, you had to FOIL this out. We did a problem like that where you had to FOIL it. I want you to take a minute right now or two, FOIL that thing out. I want to know what that thing is. Because these three parentheses represent my roots. These are called roots or x-intercepts or zeros. So let me put that. So these are x-intercepts. These are roots and or zeros. I don't know how you want to call it. So take a minute or two, FOIL that whole mess out. Let's see what you come up with. Okay. I don't know how much time we need for this. If somebody has an answer or thinks they have the final polynomial, you want to read it off for me? Okay, Caleb, what do you got?
X cubed plus 3x squared minus 33x minus 35.
Say 3x squared.
Yeah, minus 33x minus 35.
Okay. Any disagreements about the polynomial? Okay, again, I'm going to agree just because I haven't FOILed this all out in my head yet, but I knew it had to be an x cubed, had to be a third power polynomial, third degree. The reason being, there's 3 x-intercepts. So that tells me that it's going to be a power of 3 type of function. The 35 in the back makes sense because you have the 7, the 1, and the 5. When you multiply those numbers together, you do get negative 35. The middle ground is kind of the iffy part, but that looks about right. They're not like outrageous numbers. But again, how you'd actually FOIL that correctly if you didn't know, you have to FOIL these first 2 together, and whatever that answer is, you can simplify it if you want. Then whatever that answer is, then you distribute it to the back one. And then that's what should come up with this. Okay, now, reason why I want this thing. This is the actual function written out in standard notation, descending order, right? We can see the degree, you can see the potential y-intercept when you look at this. This is something we're going to talk about this chapter. But this is kind of the thing that I use when I want to mess with it, when I want to shift it up and down. This is the one that I like to use. Now, it doesn't matter. You can actually use the top one. By the way, these are the same thing in graphing calculators. So if you were to type this mess with the parentheses into Desmos, or you type the bottom when we talked about it yesterday, it'll graph the same picture. So I like to do the bottom one because it's easier to find y-intercepts. It's easier to manipulate it going up and down as opposed to right and left. And it's easier to mess with this bottom one when you wanna stretch it vertically. That's just one of the things I look at. All right, now we talked about these yesterday, and we're gonna pop up a graph here in a second of this. How do you manipulate this thing to drag it up or down? What did we talk about yesterday? What do we remember? Yeah, you add and subtract any number you want to the back number, the y-intercept number. That's something we'll talk about. So whatever number you want to put back here, if you put a +2 in the back, it doesn't even matter. It'll drag this whole picture up 2. Like that's what the +2 does. So this will shift it vertically 2. If you want to subtract it, it'll drag the entire picture. This thing that you're kind of making up, it's going to be this one, by the way. It'll drag this whole thing down. And this chapter will talk about why it's not that one. Okay? So that's what the ±2 in the back is. It's super easy. Now, again, you're actually doing that to the 35 in the back. That's what it's going to affect. So this will actually make a negative 33 back here. But I'll shift it. It'll shift it up 2. Okay? So that's kind of the idea. Now, I think the last thing we finished with yesterday was what happens when you want to stretch it. Did anyone remember how we stretch things vertically? Yeah, we multiplied the entire thing by a number. It doesn't matter what number you want to do. So, for instance, what I would do is I would just change this whole thing. You know, I would take the x cubed plus 3x squared minus 33x minus 35. I would multiply by any number I want. So maybe I'm going to multiply by 2. That will stretch it vertically. It'll still hit the same x-intercept numbers. These x's will stay the same. This spot will go twice as tall. This valley will go twice as low. And then everything else, it looks like it's stretched vertically. That's all it's doing. But every dot went twice as far from the x-axis. So even this dot right here, even though there's, this isn't any significant point, it went twice as far from the x-axis. So if that was, -1, now I'm hitting -2 down here. So it'll be right here. Okay, that's what it's doing. That's why it's stretching everything vertically. It's twice as tall. Okay. All right. Here's what you need. You need your Chromebook. So have that out. Log into Desmos. We're gonna use Desmos today for the most part because this will be the easiest way to see instant gratification. So we don't have to draw this thing out, 10 different ways to get to the graph that I want to do. Now we're gonna look at compacting vertically today. We're gonna look at shifting it right and left today. That's gonna be, hopefully we can get to that. And then we'll see if we can, maybe the last thing I wanna do today is maybe compact it horizontally. Now tomorrow, make sure you have your Chromebook and textbooks tomorrow. We're gonna do kind of an activity tomorrow where you're gonna have to move around the room a little bit, answer some questions. So yeah, just kind of be prepared for that. You will have homework tomorrow, but it should be the in-class activity that we do as your homework. So, all right, but let's get logged into Desmos. I'm gonna pull up a graph here. Graph program that looks like yours. It's just not as pretty as Desmos, but it works all the same.
Okay.
And yes, I will have people volunteer answers and whatnot today.
The B video. We got the snap. We got the snap open.
Or someone's got a B on the leash. There's someone trying to spin around a B and it's flying or not.
All right.
Where'd you find
Okay. All right. If you're in Desmos, clear out all the equations that might be typed in there. I don't know if it saved any from yesterday. Clear those all out. And I want you to type in this x cubed plus 3x squared minus 33x minus 35. Okay. And this is going to be under that y function. This is the one we're using right now. Later on, we might use the one with the x plus 7, the x plus 1, the x minus 5. We might do that one later. But for right now, we're doing this one. That's the problem. Actually, I might have to use a little bit. That's weird. Technology hiccup here. Did not like me unplugging my HDMI cable.
That's not very hard to do. Like that.
Kill me.
Oh my goodness, this thing is so slow now.
Stops. It's your fault.
Alright, take our sweet time. Alright, here's what I'd like you to do. As we're waiting for this computer to warm up and get going here, what I'd like you to do is we're going to try to figure out how to shift this thing. Like yesterday, we talked about how to stretch it vertically. Now we're going to figure out how to compact it. Now, we talked about adding and subtracting numbers in the back. That moved it up and down. We talked about multiplying the item, stretched it. So, how do you think we're going to compact it? Okay, so type that in. Put this in parentheses and try division. Let's see what happens here. So, put it all in parentheses, divide. I'll put my example up here, like what you guys are talking about.
Yeah, she does it.
So this is your chance to get a feel for how this thing works. Okay. So parentheses 3x cubed. X cubed plus 3x squared. Oh my goodness. Parentheses x cubed plus 3x squared minus 33x minus 35. All right. So now, our idea was like, this is our graph. Let me zoom out here. This is your graph that you had. Let's see if I can change this line. See if I can change the color of this thing. Oh, there it is. Why is it? Okay, let's go to, maybe we can go to red. We have a red color. That's cool. Okay, So it's in red, it's a little bit hard to see, but you guys get the idea, right? So this is my line. Now, when you divide it, what number did you guys choose to divide by?
5. 8.
Divide by 5? All right, let's go divide by 5. Okay, are we hitting, so if you look at your graph, did it hit the same x-intercept numbers?
Yeah.
Okay, did it shrink it down 5 times smaller? So here's how to check that. I know this seems really difficult, like how do you actually check if it's actually doing that? What, normally you're hitting negative 35 down here, if you noticed on the original picture. It should now be hitting negative 7 because it's 5 times shorter on the vertical end of where it hits that y-intercept. Okay, that's something you need to check. Did it actually hit negative 7 on the y-axis?
Yeah.
Did? Okay. All right. Now, instead of just dividing by 5, like if you didn't see mine, this is how my graphing calculator is showing it. I don't know. Is that what yours is doing too?
Yeah.
Okay. You don't have to just divide by 5 like that. You can actually write this, where you write out the parenthesis with all all the terms in here. You can just put a 1/5 out front. That's the same thing. You could actually multiply by a fraction. Does that make sense? What the book says, to compact this thing vertically, you multiply by a fraction that's in between 1 and 0. And that will actually, well, it's dividing, that's all you're doing. But if you want to get to a point where it shrinks. Now, that's just a scalar multiple. Scalars, you put them out front, it affects how tall it is, but it doesn't affect x-intercepts. Okay, is there any questions with how to affect height? Okay, now, let's talk about how do we actually move this thing right and left. That's one of the hardest things to actually do. How do we move it right and left from where we're sitting? Okay, we're going to leave this divide by 5 thing on it. Let's leave that, okay? But how do you move it right and left? Because right now I'm hitting, these 3 numbers. I'm hitting negative 7, negative 1, and 5. We know we're hitting that. Now it's a little bit shorter than it used to be, but this is a little bit more manageable. In fact, I'm going to zoom in just so you can see this. It's actually nicer that it's actually more compact. It's easier to see. Okay. Take this thing, it's going to kick me off in about 2 seconds. Okay, so here's my graph. But how do we move this thing to the right, maybe? Anyone happen to know how to move items to the right?
Increase the x number, or no, decrease them.
So,
No.
you're right. You're going to increase or decrease the x numbers. That moves it right and left. The hardest part about doing this is you have to go to the original problem. You have to figure out how far to the right or left you want to move it. Let's say we want to move it, let's go like 10 spots. Like we're really going to move this thing. Let's move it 10 spots to the right. Okay, so if I want to move it this direction 10 spots, this thing, this negative 7 should be at like up here at 3. This negative 1 should be up here at 11. And then, or 9 maybe, 9. Negative 1 plus 10. And then this, what is this? This 5 spot should be up here at 15 if we actually moved it over 10 spots. Okay? Now, okay, to actually move, here's what you do. You take each of these, okay? We can do it on this one or you can do it on the bottom one. I'll show you on both. What you're going to do is you're going to put a parenthesis where the x sits. So, this is the hardest part about how this works. You have to put a parenthesis where all the x's are. So do that right now if you can. And what I'd like you to do is put a minus 10 in there. Because Sam was right. If you want to move it right and left, you have to affect the x numbers. So you have to go in the parentheses where all the x's are and put those numbers in. Now I'm going to put this graph up here. I'm going to try to do a secondary graph so you can see this. It's one of the hardest things to do. I wonder if I can zoom in on this. Here. I'm going to zoom in on my equation so you can see what I'm going to do here. I wonder if I can zoom in any further on that. Alright, so I'm gonna go down to, I'm gonna add another graph over here. So, okay, so I'm gonna add a new equation. I'm gonna do the same thing. I'm gonna put in parentheses x minus 10, cube it. Not cubing the 10, but cubing the outside. So cube that. Then I'm gonna have the plus, what is that, 3 x minus 10 squared. Then we have the minus 33x, and that's x minus 10. And then the minus 35. Okay, so I'm putting x minus 10 wherever there's an x in that problem. Now I'm going to go back to my original graph here. I'm going to zoom out. So hopefully you can see what I just did there. I'm taking the original problem, putting x minus 10 wherever you see an x located at. Now if I go back and I zoom out here, what it should do, if I can graph this, if you can see this, I'm going to turn off the first graph so you can see where mine's at now. That is really bad. Like, where is this thing even at? I can't even see my graph.
Yeah, it's great.
Yes, that is the worst color I've ever seen. Why would they choose that color? These colors are terrible. You can't even see them. There it is. So it did shift my graph over. It shifted over 10 spots. If I zoom in here, you can actually see this. It is actually hitting 15. It is hitting the 9. It is hitting the 3 like we said it would. Okay, is yours doing the same thing like I said?
Yeah.
Okay, now, here's the question. Why did it move it over 10 spots to my right when I put a minus 10 in there? Anyone happen to know that? We put a minus 10 and moved it to the right. That seems totally backwards what you think it would do.
Because
If you set it equal to 0.
Yeah. If you set these equal to 0, and you add the 10 across, it makes positive 10. That's why it's actually solving it and moving it positive 10 to the right, because you actually have to solve the actual problem. That's why when we wrote these equations originally, they're always the opposite, because you have to solve it when you set equal to 0. And so it would actually give you a positive 10. So if I want to move it the other direction, maybe I want to go back. What if I wanted to move this whole graph, this thing, what if I wanted to move it to the left? What do I have to put?
Plus.
Yeah, you just change these to plus, it would have moved it the other direction. It would have moved it to the left 10. Okay? So if I would have put plus in here instead, all these would have went to the left instead. Because when you actually solve this, it would give you a negative 10, so they're going over to the negative 10 side. Okay? So, does that make sense, like how you do that? Now, did everyone do it on the original problem? Is that how you guys originally typed it in, like I did? You could have actually done it for this one as well. You could have put the minus 10 into this one as well. So you could have went x plus 7 minus 10, x plus 1 minus 10, and x minus 5 minus 10. You could have put the minus 10 into all those parentheses separately and simplified those down a little bit, and it would give you the right number. So that's how I actually did the, figuring out where it was going to go in my head. Just when you simplify this, it's going to hit x minus 3, x minus 9, x minus 15. So I knew I was going to hit certain x numbers. That's how I kind of knew it in my head. Okay, does that make sense how to shift it right and left? We talked about compressing vertically. We talked about how to stretch it vertically. We talked about how to move it up and down. We talked about right and left. The last thing I want to do, that hopefully will make sense. I want you to throw a negative sign out front. So the whole thing, you got this big, massive problem. You got it maybe on parentheses. I'm going to go back to my original problem here. Put back to my original problem. Let me zoom out here so you can see this. Wish these colors were more vivid. It's pretty dull today. Zoom out. Alright, so I'm going to take my original problem here, which is, let's say it's this one. Okay, let's say this is my original problem. This is just a little more compact. Alright, and if you throw a negative sign out front of this whole problem, if I were just to throw a negative sign and hit enter, it will switch the graph so it turns it over its end. But it's got to be out front of everything, so everything has to be in a parenthesis. So, the whole problem that you have here, like this, now I did have this one a little bit more compacted, but it's the whole problem, you know, the x cubed minus 3x squared plus blah, 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 blah. If you throw a negative sign out front of the parentheses, it will throw it across the x-axis. It'll reverse it. It'll make all the y numbers the opposite answer. That's what it's doing. Okay, so it basically inverted this thing. So I know, like when I asked that question earlier, how many people had this graph or its flip? Well, if you had the flip of it, all you have to do is make this one look like yours is put a negative sign out front. So it looks like that. You can actually see it reverse the direction. Now, you can have this thing turn around, like actually like rotate, like you can have it instead of going, you know, up and down, just taking the tails and turning the tails upside down. So, you know, like this one's up here, this one's down, but actually taking this problem and throwing it across the y-axis, because, you know, there is actually two y-intercepts over here, and there's two x-intercepts and one x-intercept. I can eventually reverse this problem, or I flip it, by putting negative signs everywhere inside with the x's. So if you want to do that, so erase this original problem, or go back to the original problem I should say, and put negative signs inside the parentheses with all the x's. And what will happen here, so I'm going to go back to my original problem just for a second, just so you can see this, then get rid of the negative sign. So here's my original problem, right? Hitting -7, -1, and 5. I'm going to throw the negative sign in there, inside with all the x's. So if I throw a negative sign in with all these x's, I don't even know if it'll allow me to do it this way I'm doing it, typing it. Nope, it didn't allow me to do that. Definitely ignore what I just did. This program will not allow me to just type what I just typed. But if you throw the negative signs in there, that was terrible. I should not have done that.
My graph.
Let's go back to the original. I don't want to type it all in again. Okay, if you throw the negative sign in, did it reverse the problem around?
I think so.
Okay, it should have taken all, you know, the -1 turned it to positive, -7 turned it to +7, and then the 5 and made it -5, and this is what the graph should look like. It should look something like this. Is that correct, what it looks like now? Okay.
It's got a bunch of ones.
Because it changed every x number across the y-axis, so it flipped them. Now, this does look like the original picture, but it's not just the reverse, it's actually like, it's a complete flop across, it's a complete horizontal reflection. This really gets people like reflection stuff, that can be really tough to actually deal with, to see the difference there, unless you understand like what's going on in the background. Okay, what you need today, before you leave, for sure, you need to write down little notes to yourself that, how do you shift it up and down? So write that little note off to your side in your notebook. So have your notebooks out right now. How do you shift a picture up and down? Write that off. Okay? How do you stretch it? How do you stretch vertical? How do you compact it or shrink it vertically? Yeah, you'd say one of your zeros would be -5. One of the roots is -5.
Oh, that's weird, one of your zeros.
Yeah, the book refers to as zeros. That's a pre-calc idea. It's why they call it zeros is where it hits the y-axis at 0.
Okay, what's 7 times 6? 42.
You're 6 at what? Yeah.
All right, now reminder.
Wait,
Hey, this week, end of the week, by Friday, I want all late work turned in. Test retakes have to be done by Friday. I think I have some pre-calc or calc kids coming in tomorrow morning. I have some geometry kids hopefully coming in today. So you got to kind of pick your battles, first come, first serve kind of a thing. So if you're gonna retake, get here early. I'll try to be here early tomorrow, and I'll try to stay later. So. Now tomorrow's tough because tomorrow after school, I mean we have meetings, so I only have about 15 minutes after school tomorrow. So that's a good day to review, but maybe not take a test. Okay, are we good so far?
No.
Okay.
What'd you get?
She's doing the crazy leg. The stanky leg. The stanky leg. Do the stanky leg. Sorry.
Alright, when somebody gets this thing all the way foiled out, I do kind of want to know the answer.
It's 2x squared plus x plus 5.
No.
What?
X cubed minus x squared minus 3x, 37x minus 25.
I'm not gonna talk about it.
Is that it? Is that,
Yeah, that's
That's it.
Hey, now, this should make sense. The reason why it made sense, you're multiplying 3 x's together, you better get x cubed. The back numbers, 5 times 1 times -7, should be -35. The middle ground, yeah, it made sense. The biggest power is going to be a 3. How I know the biggest power is 3 is how many x-intercepts did I have?
3.
3. That's what it is. The power is how many zeros or roots or x-intercepts you actually have. That's the idea. So boom, there's my problem. Okay, what we talked about yesterday, there's my graph. Now, yours might look different, yours might look like this. Fine, whatever. There's manipulations, transformations we can do to make this graph look like mine or yours look like this one. And this one, I'm not joking, this graph that you have right here looks more like mine. Now, there's little rules we're going to learn over the next week or two. Why is it that one and not this one? There's rules we're going to look at. That's the next couple sections. The section we're in right now is just how do I move it up, down, right, left, stretch it, flip it over, like that type of thing. Eventually you'll figure out like how do I know that by looking at that, that's the picture. There's check marks I go through.
Okay, so technically if there's an x squared in your function,
Yes.
but doesn't that mean that it's going to be a parabola?
No, it just means that since you're a curve, there's more variables back here, it's probably turning more than once. That's what it tells me. There's like little checks I do.
And then there's more specifics once you get to
Exactly, yeah. Yeah, so cube means, it's typically a cube looks like an S shape, like this. But since there's more letters in there, it's getting more pronounced. Yeah, there's like little weird rules that they teach you, like very shortcuts. Like, can I look at an equation and go, okay, what does that thing look like? Check, 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 check. Here's what it should be. Without having to think about what the graph looks like. Or without having to like know details about it. All right, now, here's the idea. That's the generic look. Now, don't get me wrong, they're basically the same picture. They're just kind of flips of each other. Yesterday, we talked about how do we translate this thing? Like, shift it up and down. So that was called vertical shifting. Vertical translations or shifts. What do you guys remember from yesterday?
Add, subtract, multiply, divide.
Okay, those are the basic operations. One of those will move it up.
Add.
Adding. So if I were to take this function, this is the, what is this? The x cubed minus x squared minus 37x minus 35. This thing. If I were to simply take this problem and put a +2 after it, just add a 2 in the back, it'll move this graph up 2 spots perfectly. So everything, every single dot will be moved up 2.
Didn't we do that yesterday on Desmos?
Yep.
Yes.
So 1, 2, right? 1, 2, 1, 2, 1, 2. All right, you get the idea. This is what it's going to look like. It shifts it up 2 spots. That's a +2. if I subtracted 2 instead back there, now I know that would simplify with the 35, but if I subtracted a 2 in the back, it'll move it down 2 spots. That's all it does. Simply by just adding a number in the back, it'll automatically do that to your formula. You could do that to this thing. By the way, these 2 items that you're seeing here and here, they're the same graph on Desmos. Exact same. So if I just type this in, because maybe you like typing this in better than doing all a bunch of powers, you could do that. It's just, this is a lot easier when we start getting to those later ones. Especially these first few that we're going to be doing here today. So if I were to add or subtract a number back here, like add the 2, it'll shift it up 2. If I were to subtract the 2 back here, it'll move it down 2. You can just do it like that. Does that make sense? Okay, that was the one that we spent probably the most time on yesterday because you guys had to figure that on your own. You had to like type in numbers and see did it actually work. It's kind of hard to see that when this graph is really big, like the tails go really tall and stuff. It's easier to see when it's shallow like mine. That's why I'm doing it here, not on the Desmos right now. Okay, is everyone comfortable with vertical shifting? Okay, now yesterday we talked about vertical stretch or growth.
Are you done?
Okay, so we talked about a vertical stretch. This is where all the x-intercepts would stay the same, but it makes the tails or the mid-ground taller. So here's what I mean. Let me go back to my original graph. Boom. All right. So here's my graph. I want to make it twice as tall. All you have to do, and we talked about this yesterday, is to multiply by a number. If I were to take this whole thing, this whole mess, x cubed minus x squared, blah, 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 minus 35. Okay, that. And I were to multiply it by 2 out front. It simply takes the whole graph and stretches it vertically. So every dot, this dot will be twice as tall. This dot will stay where they're at. That dot stays where it's at. This is hitting like -3, right? It'll be twice as tall, so it'll be like -6-ish. That dot will stay the same. This dot will be twice as tall. And so it's going to look like this. That's what it looked like. It looks like it's moving it, but it's really not. Notice my x-intercepts stayed the same, because if it's 0, it's still 0. But everything else has been stretched twice as tall compared to where it was originally. It's got to be the same looking graph though. Sorry, I'm not an artist, so. But you guys get the idea. Now, how do you think I could compress it? Divide. By any number you want, so give me a number. 4. Okay, we're going 4. Okay, so we're going to take my graph, and we're going to divide this thing by 4. Okay, so what that's going to do, every number, the x numbers are all going to stay the same. My zeros don't move. But everything else is now 4 times shorter if all I want to do is divide by 4. Now you can write it like that, 1/4, that's divided by 4. Or you could write this thing like this. And you could divide everything by 4, it'll make it 4 times shorter. So like for instance, this item's here, it would be 4 times smaller. This spot here would be 4 times shorter. It'd be like right there. And it's going to eventually stretch this whole thing out where it's going to look like this. But it's still hitting the same x numbers. It's just shallow. Yeah, does that make sense? Sometimes this is easier to see when you bring things back to short. Sometimes those tails, those hilltops and valleys are really far out of the picture. Just divide by number and bring them back so you can kind of see roughly what the graph is supposed to look like. Sometimes that's nicer. Like this to me, like this graph is always pleasing. But if you actually graph it, these things can be way out there. And it's really ugly. So dividing by 4 can bring it back. Does that make sense for vertical stretching? Okay. Those are kind of the easy ones. Those are ones we did yesterday. The hard ones are the ones we have to focus on today. What I want to talk about today is what happens when you want to move it right and left. Right and left. We haven't done that. We did multiplying, we did dividing, adding, and subtracting. But how do I move it right and left is a brand new thing.
You times it by a polynomial.
Nope.
You do your parentheses and then you subtract.
Okay. You do your parentheses here or in this problem. I can show you both, but you add or subtract in it. That's the hardest part most people don't get.
Did we kind of do this in algebra 2?
Yeah, you should have. It should have been something very, very similar in algebra.
Probably don't know how to do it.
Yep.
But I don't think we were moving it like lines. I think we were
Were you doing groups there or was it just lines?
I don't know.
It was first? Okay.
I don't think
We learned how to get
that.
that.
Okay, alright.
I don't know.
Now, how I'd move this thing. So do we want to move right or left?
Right.
Right. Okay, we're gonna go to the right.
So it's positive, right?
So to move it to the right, this is the goofy part. If I want to go to the right, so this is going to be a horizontal shift. This is brand new. And this is the part where you will need your Chromebook today. Okay, is this, I want to graph the original and what we're going to do to it. Okay, so I want to shift this thing horizontal and I want to go to the right. And now, how many spots do you want to go? 2. We're going 2. I like 2. It's easy. Okay, we're going to go to 2 to the right. Here's what you do. In every single one of these variables, you change the variable so it's like this. You're going to subtract 2 on the inside. Not add 2, which I know is totally backwards of what you're thinking. You're going to subtract 2 on the inside of each variable. So wherever there's a variable, you're going to put a -2 on the inside of it, like this. Ooh, sorry. It's a 37, you're going to have an x -2, and then the -35. The 35 doesn't have an x on it. Notice, every x came out and became an x -2. You're putting a -2 inside of wherever x is. Now, if you went down here and you did it to this green one, same thing, you subtract 2 in here. And that would just simplify those numbers. It will shift everything over 2 spots. This graph should look like this. Should be here, should be here, should be here, and it will be the same looking graph.
Oh, I know what we did. We did stuff with absolute values.
Oh, yeah. Yeah, we're not doing that yet. Okay, alright. Log yourself into Desmos. Everyone at your pod should have at least a Chromebook. If you don't have a Chromebook, look out for somebody next to you. You will want to see it. Okay, I want you to type in the original function in the first line, this one. Then in the second line, I want you to type in this one, and it should be a different color. I want to see that. I want to see this one in your original, and then that one in the second one. Okay, I'm going to walk around the room. I'm going to check, are you typing this in? Does everyone at the table see how you did that? So I want this one in your first function, that one in the second one, right there. That one. In fact, let me get your graphs, you can see that a little bit better. Okay. Light is affecting that thing, there you go. So this is what you're typing in the second one. I want to walk around the room, I want to see it. Can you graph this correctly? Everyone in the room needs to be able to graph this.
What's the first one?
This one, it's your original function.
Sorry, that looked good.
Now you might need to zoom out because this thing will go like crazy. And then we can shift it right and left twice. Got it? Yeah. Yeah, that's
Which one do we do?
Let's do this. Let's put a fraction up front to make sure that maybe this looks a little bit better. Let's go with, is there like,
It'll be the same graph.
yeah, let's go with like 1. Might be the earlier. Yeah,
You can take it. Yeah.
there, that brought it back to a little bit more normal looking, didn't it? Perfect. Okay, now I know this thing looks terrible, right? Because you're looking at it like the tails go up forever. It's really hard to see this thing. For what I did with Sabrina here, just to make sure like you could actually see what this thing looks like. What we did on hers, on the first problem, we divided it by a 4th like I did earlier, because that brought the tails back down so it looked more normal. So it kind of looked like my picture. So just put a 4th out front of the original by putting this in parentheses. That'll bring the tails back to more like mine where you can actually see them. Because otherwise, they're so high up and down, like you can't even get a sense for what this thing is doing. It's doing something like that, and it's so hard to see in your viewing window that you can't even see where this thing is going. So if you divide by 4, it brings them back down to respectable levels like mine. And now you can actually see that it has shifted over twice.
You divide this up here.
Yeah, and then this one as well, you can divide this whole thing by 4 or put a 1/4 out front. It'll look pretty good like that. It'll look like it shifted. So, it was just something like, sometimes it's nice to do that, just divide by 4. You know you're bringing the tails back down, but you can at least get an idea of what it's looking like. If you don't want to divide by 4, that's fine, just leave the original functions. See, if you back up front, it does look okay. Yeah.
Mr. Ward. If I give this to you, does that send me up the last one? Why did you say Mr. Ward?
But after that,
Madison, are you doing basketball?
Oh, does he just give you the QR code though?
What time are you
You have to go scan it?
And then,
Oh, yeah. You divided yours by 4. Yeah. Makes it look a lot better. Alright, get back in the grass.
just say, I'll be like, oh,
Yeah, that looks good. Alright, can I borrow that?
if anything,
Oh, wait, I don't have it.
so fast.
is it red?
I don't want to do it. I don't want to save
Now
it
you
there.
got that.
Plug it in yet. We'll save it for later. Okay, alright.
Yeah, you do.
Okay, next. The next thing I want to do. We shifted it to the right. Now we're going to shift it to the left.
We'll change all the negatives to positives.
Yeah, so here's the idea. If you go to your graph, and instead of shifting all these to the right 2, now why it's shifting it to the right 2 is because you'd have to actually set each of these equal to 0. And if you do that, you actually get a positive 2. That's why it's actually going to the right. Even though it looks backwards like it's a negative, that's why it's shifted to the right, because when you solve for 0, it actually goes positive. So if you want to shift this thing to the left, this original picture this direction, all you have to do is put a plus in here instead. Now, let's not do 2. Let's go like positive 12. Go, put a plus 12. It's going to send this thing to the left 12 spots. Okay, sorry, that's me. Apologies.
Golly. We're not thinking your phone can caddy.
Now, somebody messed with this. They changed all my settings, logged me out of a bunch of stuff. I changed because I didn't use my passcode to get on my phone. So now I'm not putting it back there anymore.
Wow.
How'd they know you're good?
So I don't have different passwords. I use the same password for like the
And you
one.
can't cross your line.
So, but yeah, they logged me out of a ton of stuff.
What settings did they change?
They turned off my, they turned off Wi-Fi. They turned off cellular. They turned off a bunch of other things. They logged me out of a bunch of different things. Like I don't even know the passwords to them. So like, I was pretty mad.
Wow.
To my phone.
You know who did it?
Yeah,
It was somebody sitting back row one day. They just like totally messed with my
They're
phone.
customers.
Brenda begs to differ.
No, it won't go back there anymore. So.
Nobody has any.
All right.
Yeah.
Okay. All right. What do I need to do? Type in 12. Hopefully you do it on the problem where you have the 4 on it, so it looks a little bit easier. This one I'm going to use for yours because this will look a lot better. So, all right. Pop it up here just so you can see this. All right. Let's get rid of that. Okay, you want to go with that plug in? All right. Get a switch for that. I'll have a switch. Okay, so we can definitely see her equation. She has a really good looking graph because it had the divide by 4, so it brought it back to like, so it's easier to look at. So, and we're going to shift it to the right 12 spots. Okay, there. Okay, oh yeah, perfect. Okay, so you can definitely see her original ones in red. And now what she did, she took this original graph and she put the plus 12 in there and it drug it over 12 spots. So if it was going to hit 7, now it's hitting -5. If it was hitting -1, now it's hitting -13 down the road. If it was hitting -5, now it's hitting -17 down the road. So everything's been shifted. So this is the graph that you're getting now. It's this one, as opposed to the original one is over here. Like that was the original one. So it's definitely been moved to the left 12 spots. So it's just hard to see that. That's why dividing that thing by 4 brought those tails back. It's easier to see. What we do in Calc 1 is we'll eventually find how to find like these points. Like how do you figure out how tall those things are? We'll eventually find that out. That's a part of like a big part of Calc 1. That's like this 3rd chapter we do. All right. Thank you. That was really good. All right. Perfect. Yeah, just
Stop it up for the day?
Thanks. Oh, that's nice. All right. Okay. All right. Today, the last thing I want to make sure of is that you guys are comfortable with graphing, because we haven't done every type of graph, right? We've moved it right, left, up, down. But the one thing I want to finish with last is to talk about that one problem that I saw. It was Crew. It was your picture that you had earlier. This was your picture, correct? My picture didn't look like that. My picture looked like this one over here, just kind of knew what this thing was going to look like to start with, where I did this. That was mine. His was backwards. He went, he started up and went down. all you have to do to get to this graph from mine is take your whole problem, whatever your problem was, and all you have to do is throw a negative sign out front. It dumps it over the x-axis, so basically it'll look like this. And it just goes the opposite direction. It's a perfect mirror image of what the original one was.
So
The original one's a dash.
So that'd be like a mirror flip.
Yeah, it's a perfect reflection, mirror flip, across the x-axis. By just putting a negative sign out front. If you want to go across the y-axis, you have to put the negative signs on the inside of each x. And we'll talk about that tomorrow. Tomorrow, for sure, you will need a Chromebook to help you graph problems. You will need your notebook. You'll need your textbook. We are going to get an assignment tomorrow. Now, I know I won't be here in class. They'll have a video for you to watch. It'll have you kind of moving around the room trying different things out on different stations. Just go with it. Try your best to keep up. Hopefully Mr. Graham will pause it for you a couple times. Or I'll have somebody in charge of like pausing it when you get to a spot where you have to try out a problem by yourself and give you enough time to do it. But it will have homework, and it's based on graphing like what we're doing here. You will need graph paper tomorrow. I'll have it when you walk in. It'll probably be in the back caddy back there, so you can pick up graph paper for the homework tomorrow. You only need 12. I'm going to have you graph 12 things. So. Oh, yeah. So, yeah. So I'll have graph paper in the back.
Paper. So what Brian can do, she's gonna
Yeah,
the same size.
All right, but that's it for today. We're done. So yeah. So we have
So she's gonna buy the same size also.